Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the fifth lecture of chemistry first year. The chapter name is thermochemistry and the topic name is thermodynamics and internal energy. First is what is thermodynamics? Thermo is for heat and dynamics is for flow. You have already studied about the concept of static and dynamic. Static is for the state of rest and dynamic is for the state of motion or flow. So, thermodynamics deals with the flow of heat or any other form of energy into or out of the system. Thermodynamics is the branch of physics that studies the effect of changes in temperature, pressure, and volume on the physical systems at the macroscopic scale by analyzing the collective motion of their particles using statistics. So thermodynamics is derived from the Greek word thermos mean heat and dynamic mean flow. Here we have to study some terms used for the thermodynamics, that is system. System is a specific part of the universe or anything which are kept in consideration is called as system. The specific part of the universe is called as system. What is surrounding? The rest of the system is called as surrounding. So everything external to the system, that everything which surrounds the system is called as surrounding. Boundary. The layer which separates system from the surrounding is called as boundary. Or the thermodynamic system and surroundings are separated by an envelope called as boundary of the system. And the universe is the combination of all these. That system and surrounding makes universe. For example, if we boil the water in a beaker, the water is a system while the heat which we are providing to water and the beaker is surrounding to that system. So the beaker and heat source is the surroundings. Consider the reaction between sodium chloride and the silver nitrate solution, which can be called a system under observation. The flask and the air are the surroundings. The instruments that we are used are surroundings, while the main substance or material upon which we work is system. For example, you all are sitting in your class, and the class contains some specific part of the universe or some specific part of the school. It means that your class is a system and the surrounding is grass, remaining classes, rest of all the classes are your surroundings. Then you have the system. Now, thermodynamic state versus path functions or state functions. What is thermodynamic state? A particular thermodynamic state is characterized by a few macroscopic observables. It means a change in the state happens. How a change in state can occur? By changing temperature, pressure, or volume. As you have already studied, you have the concept of rate, that how rate of reaction changes by changing temperature, concentration, pressure, volume, etc. How the state of a substance can be changed, how a state of a system can be changed by changing temperature, pressure, volume, and altitude, etc. So, in thermodynamics, we study changes in the state of the system. The state of the system is defined as the values of macroscopic properties such as temperature, pressure, volume, energy, and composition. In other words, the state of the system is the condition of the system in terms of temperature, pressure, volume, and composition. These are the macroscopic properties, means they bring about the high change. They bring about the great change in the state. State functions or state variables are the properties that are determined by the state of the system and dependent only on the current state of the system and independent of the path. They are depend upon temperature, pressure, volume. Independent of the path means what path they are following for changing one state to another. This is independent of the path by which that state is reached which we require. It means that when the state of system changes, the magnitude of the change in any state function depends only on the initial and final states of the system. The initial states when we have no effect of temperature, pressure and volume, and the final state when we change the conditions, that is temperature, pressure, volume, and the final state of the system that we have, and not on how the change was carried out. It means that it is independent of the path, no matter what path we are following. We have to only change the state from initial to final. So in the state, one state is changes to other by changing temperature, pressure and volume. Initially the temperature is T1, volume is V1, pressure is P1. When we are changing the state, we are changing the conditions of these parameters, that is temperature, pressure and volume. So then the final temperature will be T2, volume will be V2 and pressure will be P2. So a change in state is accompanied by a change in parameters such as temperature, volume and pressure. If 1 mole of a gas in a state of V1 at temperature T1, now we are heating and T1 is heated to a temperature T2, the volume of the gas becomes V2. First the volume was V1. Now when temperature increase, volume increase. You have studied in Charles' law that volume is directly proportional to the temperature. Temperature increase, the reaction rate will be higher and the volume will also increase. And it becomes V2. While when temperature decrease, volume will decrease. Hence V1, T1 specifies the initial state, while V2 and T2 is the final state of the temperature and volume. The change in temperature changes the volume of the system. Hence, such properties like volume, temperature and pressure, in which the change in one property changes the state of the system. These properties are changing the state. It means that reactants are converted to product. In simple words, reactants, by changing conditions of temperature, volume and pressure, the reactants are converted to product. It is called as state variables or state functions. Now there are two characteristics of the state function. I have already told you that a state function is that property of the system which depends on the initial and final states. Initial and final states of temperature, volume and pressure. While it is independent of the path adopted to bring about a change. For example, if we heat a sample of water from 0 degrees centigrade to 25 degrees centigrade, it means that we are increasing the temperature. So the final temperature is 25 degrees centigrade while the initial temperature is 0 degrees centigrade. The change in temperature is equal to the difference of the final and initial temperatures, that is T2 minus T1, higher value minus lower value. This is the simplest example of water, that first the temperature of water was 0 degrees centigrade. Now we start to boil. We start to heat and now the temperature of water is 25 degrees centigrade. It means that 0 degrees centigrade the temperature was T1. It is the initial temperature state. While the temperature at which it is 25 degrees centigrade, it is the final temperature state. And when we conclude the difference of the temperatures, it means that T2 minus T1 or T final minus T initial. Similarly, we can calculate pressure and volume. Likewise, initial pressure and final pressure, initial volume and the final volume. Second characteristic of state function is that when a state of the system is specified by giving values to some of the state functions, it means we are taking one state function and we are assigning values to that specific system. Now the values of all other state functions will be fixed. For example, we are giving values of temperature and volume. Now the other state function, that is pressure, will be fixed. The value of pressure will be fixed. For example, if 1 mole of a gas occupies a volume of 5 decimeter cube or 6 decimeter cube or whatever the value is, at 25 degrees centigrade. The pressure must have some fixed values. It means that we have assigned the values to some specific state functions while all other state functions values are fixed, for example pressure. However, there are some state functions, there are some properties which are path dependent. I have told you that state functions are path independent. They only depend upon temperature, pressure and volume. They are path independent. However, there are some properties which are path dependent, so they are not state functions. For example, heat and work. The heat is path dependent. That are not the property of the system but simply represent mode of transfer of energy from the system to the surrounding. This is the examples of the state functions. I have said that heat and work are not the property of system. They only represent the transfer of energy from system to surrounding. So in general, in state, a state changes by changing conditions, that is temperature, pressure and volume. The initial temperature is T1 while the final is T2. The initial pressure is P1 while the final is P2. The initial pressure is V1 while the final is V2. It is independent of the path, means no matter what the path it is following to change the state. So this is the general point of state and state function. However, there are some properties which are path dependent and that properties are heat and work. If these will be path dependent, they will not be state functions anymore. Now what is internal energy? Internal energy is represented by E or U. This is the total of the kinetic energies due to the motion of molecules, that is translational, rotational and vibrational motions, and the potential energy associated with the vibrational and electric energy of the atoms within the molecules or crystals. So internal energy is the sum of all possible types of energies present within the system. A system contains all possible types of energies. Internal energy will be the sum of these all possible types of energies. Internal energy is also a state function. It is the property of the state of the system. This implies that the change in internal energy between two states of the system is independent of the path followed. Mathematically, we can write as we note internal energy with E. So the change in internal energy from initial to final state is E2 minus E1. In the internal energy, the heat and energy of the system get transferred from system or to the system. These two ways of transferring energy from the system to surrounding or from surrounding to the system are heat and work. The two ways of transferring energy are heat and work, from system to surrounding or from surrounding to the system. It can also be denoted by U. So the change in del U or internal energy, if del U, that is change in internal energy, is greater than 0, it means that there is gain of internal energy or sum of energies. If the change in internal energy is less than 0, it means there is loss of internal energy. Del E or del U is the heat change when the reaction is carried out at constant volume, while del E is equal to QV, where QV is the heat supplied at constant volume. Del E is heat change and QV is the heat supplied. As we have studied, that temperature increase, kinetic energy increase, internal energy increase. Similarly, temperature increase, kinetic energy increase, internal energy increase, and a phase change can occur. It means a liquid can be converted into solid or a solid may be converted into liquid. Melting or evaporation processes may be occur. The temperature happens, the reaction happens when the reaction conditions changes. It means that when we decrease or increase the temperature, volume or pressure, the reactants converts to product. It means that when temperature increase, kinetic energy increase, internal energy increase, and melting or evaporation can occur. One phase can change to other, or one state can change to the other state. Similarly, when internal energy increased by increase in kinetic energies, it results in a chemical reaction. If energy supplied is sufficient to break the bond, it means that the old bonds are broken down and the new bonds are formed. This is chemical reaction happening. And this is because of increase in internal energy, mean temperature increased and kinetic energy increased. So the increase in internal energy depends upon the three factors. When internal energy will increase, temperature will increase, kinetic energy will increase. When internal energy will increase, a change in phase can occur. When internal energy will increase, a chemical reaction can occur. This was all about internal energy and thermodynamics. Thank you so much.